Morning. Hi, thanks for coming to my talk. Today, I'd like to talk about what you can learn from Elixirs HTTP Middleware Plug. And the original title of this talk is actually just enough plug to build a web server. And there's a certain reason why I'm referencing back to this original title. And you will see this in a bit. My name is Ole Michaelis. You can find me on the internet with my handle almost everywhere on these social networks. I am running the local Elixir user group. I already do see some familiar faces. So cheers. Thanks for showing up. And professionally, I'm an engineering manager at Simple. So we do lots of awesome stickers. I even brought a few. So if you want to stick around for the next 30 minutes, you can afterwards come up and grab one of those. But we also don't only do stickers. We also help you to automate all your domain management needs. With Simple, you can register, transfer, and manage all your domains using our easy-to-use REST API. And we also offer you the tools you need to help your customers to get their own name for your product. So let's jump right in. This is a pretty wide conference, right? It's many technologies are discussed here. So I want to give you a very brief primer on what Elixir actually is. I like to start with a show of hands. I hope you know Elixir. Coming here. That's one hand, two. That's great. Three. So for the rest of you, this will be pretty deep. So I hope you can steal something out of that. It might be a good learning opportunity, right? So Elixir as a language is functional, immutable, and pretty versatile. And we could spend a whole talk discussing each of those keywords now. But summing it up is it pretty much also looks like Ruby. And that is true, but this is really just the syntax. So don't get confused by things that really do look like Ruby, but they're not. And you will see in a bit why not. So let's revisit the title. Just enough plug to build a web server. Let's dissect this. Let's see what's really in here. So first we have plug, then we have the web server, and we have the building part. And throughout this talk, I want to talk about each of these three things with you and my journey around that. And also, I want to show you what you need to use plug and what you can take away from that for your day-to-day programming life. Let's start with the HTTP middleware plug. So plug is pretty similar to what you might know from Ruby as Rack or from Python as WSGI. It's a API, it's a set of APIs. It's not even enough that I would say it's a framework to do HTTP. It's an HTTP interface. And when you check it out on GitHub, it has above the fold two key phrases or key lines specifying what it is. So first, it's a specification for composable modules between web applications. And second, it has connection adapters for different web servers in the Erlang VM. And especially that part, we will revisit that in a second as well. So what does it actually look like? Maybe you haven't seen plug in action, how you would use plug, what it can actually do. So this is a little bit of Elixir code here. We define a module, then we import all functions that are in the plug con module. We need to initialize it. See if we can do this magic here. Oh, yes. So we can initialize it here. And then we have a call. So this is basically the two-step. This is the interface of plug. This is how you can do very basic HTTP stuff. But this also is the foundation to build way more complex things. And we'll see this in a bit as well. So what are we doing here? We're calling our plug. We are putting the response content type as text plain, and then we are sending out the response with the HTTP status code 200 and the body of hello world. So we'll come back to this. But this in itself is pretty boring. And in order to understand why plug is so powerful and interesting, we need to look at the concept of having a plug of plugs. So you can combine those. This is really where plug shines. So it looks similar. We just start out with a module. Then we use that macro called plug builder. And here we can specify plugs that should be called and used before this plug we are actually defining here ourselves. So it follows the same interface here. and you still need the call function. Super calls the plugs above, and then this assigns here is basically just a demo. This is putting like an internal state on the plug connection. Looking at this, and especially to the folks who have been using Elixir already, you have seen this, and I'm pretty sure you have seen this before, because if you have used that cool web framework that basically everyone in the Elixir world is using, this is the Phoenix router. It's basically the same thing. The Phoenix router has a lot of like sugar coating on top of it, but it still has the macro you see at the top. There's a pipeline where you specify a plug of plugs. So you're putting together multiple things that in the end are your web server. So that's pretty impressive, right? So under the hood, the Phoenix router is a single plug. So just enough plug to build a web server. What's in here? The web server part. Let's see. So the web server. Let's address the elephant in the room. Like, who with the brain in the hat would actually stand out and write a web server themselves? Turns out, I did. I found myself running a web server a few years back for the giggles. Like, I wanted to understand. I was actually intrigued by the HTTP 2 protocol, and I wanted to like play around with it, and found myself saying like, actually can't be that hard, right? And turned out it was pretty intimidating, but I learned a lot, and I also learned how to interface with Plug, and this is basically the distillery that came out of this stupid idea of writing my own web server. So I took those learnings, and instead of wanting to write a web server that actually works, I wanted a web server that just barely works. So I came up with this thing called Stupidify that is just enough code to run a web request. And this is what we'll have a look at today. So in this talk, we want to revisit what Stupidify is, what it can do, what it can't do, and why you should totally not adopt any of what you see on the slides in your code base, because this is not the great part of Elixir, right? I just built this to showcase what Plug can actually do. So in Elixir, we have this saying, just let it crash. And it might sound counterintuitive, but the idea is that you let your application crash, and then the OTP platform can handle that and restart your application. So Stupidify just crashes. There's no observer, it doesn't get recovered. Also, I'm using all the patterns wrong just to make it run like with the least boilerplate code possible. So bear that in mind while we look at it. And we'll also leave out some details. So to get us all on the same page, let's have a look at the HTTP protocol. I think most of you have seen this before. So we start with a... Wait, we can do this better. Let's make it this. Awesome. So we start with the request and the request line. The request line consists of the verb, the path, and the protocol version. So in our case, it's a get on the root on HTTP 1.1. 1.1 was the last HTTP version that was plain text. And this is why it's so easy to like read and talk about. The others, while still following the same concepts, are just way more complicated and would be hard to showcase binary data here. And then we have the request headers, and we have a maybe body. And then on the response, we have a status line again with the version, the status code, and then basically the same information, but in string form. Personally, I think that is not very smart, and I have way more fun stories around the reasoning phrase later in this talk. And we have more headers. So these are the response headers. And headers are pretty interesting in HTTP. I don't know if you ever realized that, but at first glance, this is a key value thing, right? You have the key on the left-hand side and then a value on the right hand. But HTTP makes this more interesting because depending on the key, so depending on the information you want to read, the data format on the right-hand side, so the value, it depends. So the date, for example, this is specified in RFC. Like the date always has to follow the same format. You can have a pretty simple parser to parse the date. Another simple example is the content length. That's always an integer. Now let's have a look at content type. Content type is first a string, but it's also a list, and it's separated by semicolon. Look at the accept encoding in the request headers. That's a list as well, but it's separated with comma. And cache control, why not in this example, is another list, but it's separated with space. So if you really want to make sense of the data in here, you need like different parsers for all those various types. It's madness. And then my favorite example when it comes to parsing, look at location. I don't know how much experience and exposure you had to parsing URLs. There's a lot in here, right? There's the protocol, then there's the domain or the host, that consists of the TLD, ETLD, registerable name, subdomain, then we have the path, the query, the anchor, and all of that, right? Just parsing that, all the information you can hide in here is a lot. So headers are a madness. And there's also response body, but like for this talk, we just like glimpse over it. You can do even way more crazy things with that, right? Like returning an HTTP 200 and giving your error response in here. Like we all have seen that. So let's talk about the interesting bit of really building a web server. So let's talk about the build step. So the 5 simple steps to build your own web servers are: you need to listen to incoming TCP requests. You need to accept those requests. You need to parse the actual request from the line. You need to delegate it to something that can make sense of this request. And you need to respond to that request. So let's revisit all of those 5 steps here. First thing is listen. So in Stupefy, listen follows the same interface as a gen server. But as I already mentioned, it's not a real gen server for many reasons. I just wanted to have the ease of starting it with a IEX, like a short console command, and don't want to write my own thing. So we start by using gen TCP to listen on a specified port that comes out of the magic from here in this example. And we specify it as receiving binary data. And for those of you who are not familiar with Elixir, in Elixir is string data is binary data. And given it's just encoded in ASCII on the protocol, just receiving binary data actually gives me a string. And otherwise, if I wouldn't specify that, I would actually retrieve a list of characters. And that is way harder to work with. Then also packet line makes gen TCP to just give me each thing line by line, so I don't need to parse all the new lines. And active false just makes it easier to work with in a sandbox environment, because gen TCP receive would actually block until data is available. And then here's the first hack. I needed to use a task to actually start the loop, but not block on this call. So this is now executed in the background. And this is the acceptor loop. So we pass in the socket and our plug and the init, or whatever is returned there, which is empty list. And then we return. So that's the listen part, right? This is on a very basic TCP level. We're accepting or we're listening for new connections. Now we need to accept whenever there's an incoming thing on the line. So that's the loop acceptor you just saw. Again, we're using gen TCP to accept whatever is coming in. And then we have this little bit of code. So we call serve, and whatever that is generating, we respond. And we'll see in a second what serve actually does in the inside. You can see that we're already passing in an empty request, an empty Stupefy request. So we build this up and then pass that request to respond. And as I said, because we're doing a very simple, stupid version of the HTTP server, we just close the connection right away. And then we use what's called tail recursion. So to make it a loop, we just call ourselves again with the same information. Seeing this, you might also notice that the web server we've built is not multi-threaded, right? We can handle one request at a time, and then once that is handled and we close the connection, we'll be ready to accept the next one. Let's have a look at the Stupefy request. It's very stupid because it doesn't do much things. First, we have the awaiting, which is basically me building a state machine to pass the correct things. Then we have a list of headers and the status line. So let's take a look on how we pass that, how we pass the actual request from the socket. So this is, again, very Elixir specific. So we have a multi-header function definition, and we start with a terminating function. So if we receive something that is awaiting a response, we just return the request and we don't call serve again. So here we're using the state machine. And then we have the actual implementation of this where we call serve. Then we have the socket, we just pipe it through readline. Readline here is a very thin wrapper around gen TCP readline, so it's really just reading a line. And then we pass that to parse, and we return the request. And then we call serve again. Again, we're using tail recursion here. So the next thing we need to do, we need to parse out the data from we need to pass the request, right? We need to build it up. So here we see the function definition of parse. Again, we end with the terminating function. So if we are awaiting the status line, or this is not the terminating function, this is the starting function. If we are awaiting the status line, we know that the request just has been built, so it's the first thing our request needs. So we know whatever data comes in, it's the status line. So we just update the status line to data. And now we also know that we are awaiting the headers next, because there can't be two status lines. So continue parsing. If we receive empty data, but we're awaiting headers, we know that we can move ahead in our state machine. Right? We don't await any more headers because there is no more, because we're awaiting headers. So we set the next awaiting thing to actually send out the response. And then we have where we're actually awaiting headers and there is data. So we just pass out the data, pass headers. It's basically here really just like splitting as key value pairs and ignore the internal data structures of that. And we're awaiting more headers. So that's the web server part. And now we need to connect it to Plug, right? You saw the Plug at the beginning, and now we need to put it together. And this is the delegate phase of building our web server. You saw the response function earlier, and there's a lot of cool stuff hidden in here. So let's have a look. We have those 3 arguments here. So it's the request, then we receive the plug. It's a tuple, so we deconstruct the data structure in the header, and also receive the socket. And then we, on our request, that's the Stupefy request here, we build the connection. And this is where we basically put our Stupefy web server and Plug together, because the connection is that thing that Plug really needs to work, right? It defines what Plug really is. It's basically the set of APIs that I mentioned earlier that Plug really is. And then we call whatever Plug we have received or was passed in, we call with the options. So it's basically just like we have received that data. We will see how this is constructed later as well. We're just calling the Plug. Let's take a look at the Plug connection. This is the one base thing of Plug. This is really where all the magic happens. It's a simple struct with 27 different fields, and it has a massive 134 lines of documentation. So it's really extensively documented, and that's really cool because there's a lot of stuff in it, and there's a lot of stuff to learn. And it also represents the entirety of a Plug request response thing. So there's 5 categories of requests and of fields in the struct. The first is the request fields. Then there are fetchable fields and response fields. Those are, for our HTTP lifecycle, the most interesting fields, right? So we start out with the request fields, where we have the obvious one, like the host. So in our example we had before, it would be www.example.com. There's the method, so that's the HTTP verb, get, post, head, options, all of those stuff. Then we have the request path, again, that's from the status line. We have the port, we have the peer and the remote IP. I don't know how much I want to go into detail here, but the difference there is the peer is the actual TCP peer. That is the other end of the TCP connection we are connecting to. But this does not necessarily have to be the actual client, right? If you think of an architecture where you're working with a load balancer, the TCP peer you're connecting to would be the load balancer. And remote IP is a field that's reserved to be set by a different middleware that understands whatever infrastructure you have. So for example, if you're running behind a load balancers often set this x-forwarded for header that actually contains the remote IP. So the remote IP field is left blank in the web server implementation for any middlewares that can actually parse this out. So that's the difference in here. Then we have request headers, the scheme, which you could translate to the protocol, the query string, and a few more. But this really is what defines a request in Plug. Then we have fetchable fields. Fetchable fields are different to request fields in a way that they are initially left empty and you need to explicitly fetch them. This is done for performance reasons, right? There could be very big data chunks in there, or things that require massive computation to fetch them and compute them. So you need to explicitly fetch them before you can actually retrieve them. First it's cookies, then we have a set of various request params, and then the params jump combined. And then we also have request cookies. This is meant to be just the cookies from the request. Then the cookies is basically everything that we already have set in other middlewares, plus the request cookies. And you will see that there's another cookie thing coming up in a bit, because there's also response fields, and there's a response body, and the response char set, and the response cookies. So here you see how cookies is basically constructed. The response cookies are the cookies we are setting in the HTTP response. And there's response headers as well. And the status. Interestingly enough, as I mentioned previously, Plug only defines the response status code digit. So this would be like 200 in most cases. And it does not carry along the reasoning phrase. We'll see in a second why this is. There are also private fields like the adapter and the private struct field. That is really just for internal reasons. And then there's fields that are just meant for the connection. So it's meant to share data in between different Plug middlewares. The most well-known one is assigns. That's basically a data store. Like that's the one field where you just can push everything in it. There's the owner. That's also for the connection. If you want to reference your conf field to the actual TCP connection, imagining you can handle more than one request, you need like a sort of identifier. And also a halted flag, a secret keybase. Most developers, Elixir developers know this because you need to set this to make a test pass, because it's initially empty because it's secret. So they, intentionally don't preset it. And that's the state, representing state machine. So jumping back to how we actually need to construct this, we receive the empty request and the socket. And then what we're doing here is we actually want to convert our stupefy request to the, Plug request or the Plug connection. So first thing we do is we pass out status line. Basically, we are separating by white space. So we get the verb, the path, and the version. We just convert the headers into a map. Pretty straightforward. Be warned, in HTTP, it's okay to have the same header specified twice. And doing this would just override it. So again, this is another of those bad examples that you shouldn't copy. And this is how we would construct the Plug connection, right? We set all the necessary fields for Plug to work. So we set the host from the host header. We set the verb as the method, request paths, request headers. The scheme, we just default to plain HTTP. We specify our adapter, and that will be interesting in a second as well. And then also the owner of the connection, which in our case is just the process we are running in currently. So jumping back to respond, we now have built this connection, and we are passing this connection, this Plug connection, to Plug. Right? This is how we connect it all together. Like we have just built from our web server implementation the Plug connection struct, and pass it to whatever we have received from Plug. So let's revisit. What was a Plug again? That is the Plug we wanted to run, right? So we have we import all the functions from the Plug connection. So that is all the functions that can work with the connection struct we just built. And those, for example, those are examples of that functions that we imported. So Plug gives you the functions necessary to work with the connection object, like put response content type, sending a response. And all of that is not, you don't need to specify this in your web server nor in your application. Like that is the part that Plug takes care of. Now let's have a quick peek into how Plug actually looks like internally, so we can understand how it works and how it actually talks to our web server. So here you saw send response. We are receiving the connection. Remember, that is the connection we have built up in Stupefy that now holds the adapter and the payload. In our case, the adapter and the payload. The adapter is a module namespace, so that's Stupefy web server or Stupefy server, and the payload is just the gen TCP socket. And it can be any Erlang term, right? It can be any term you can store as the payload. And the contract of Plug is actually you give it to Plug, Plug takes care of it in the connection and hands it back to you if you ever need to send it out again. And then on the adapter, as you can see here, there's send response called with the payload. So here's how adapter and payload from the connection are put back together, right? And then we also pass the status, the headers, and the body. So only the things that the web server really needs to actually send it out on the wire. So this gets us back to respond. So now Plug has built our web request, right? We set the HTTP headers content type as text plain, and we send hello world. And now we need to respond. Like now we need to send it back over the wire on the HTTP, on the TCP protocol in HTTP form. So this is the send response implementation of Stupefy. First thing we need to do, and here we are looking at reasoning phrases again. Funny enough, in Plug, you can override reasoning phrases. So I can specify in Plug that I want 200 to be reasoning phrase okay-ish. Or 301 can be log elsewhere. Like you can do whatever you want there. And I don't know really like why they made the decision. But it's recommended for web servers implementing Plug to actually follow this and fetch it from Plug. Then, again, write line is a very thin wrapper around GenTCP. We are just sending a new line to the TCP socket. We hardcode the HTTP version. We send the status and the reasoning phrase on the socket. Then we are sending headers. This, again, is a Terry recursive function. So we just send header line by header line until the list is empty. And then we are writing an empty line as by the protocol specification. There need to be a new line or an empty line in between the headers and the response. And we write the body. That's about it, right? This is how we send the entire request out on the wire. As part of the protocol, we need to return a tuple consisting of 3 items. It's the symbol OK. The second one, that's actually really interesting. The second one is supposed to be the send content, but only in test environments. So if you want to write specs, then it's super handy because the content that was sent over the wire is actually returned. But in production, you should not do this in order to not give a false sense that you could actually still modify the body, because the body is sent already. If you would allow it to modify or just read it anymore, it wouldn't make a whole lot of sense. And also, because it depends on the web server implementation, you need to return a new payload. So with socket now, it could happen that we have transformed it in any way, like if it's like a map or something that needs to be updated, right? In our case, it's not that important, but we need to return anyway. Plug also ships with a set of adapters, and I say adapters with little asterisks there because the adapters supported are Cowboy and Cowboy 2. So that's all the variety we get. But it's fine. Like Cowboy is a really reliable web server, so it's fine, and they both support the same set of adapters. Obviously, if you want to build a whole web server, there would be more, right? The interface is a little longer, so those 6 functions or those 6 callbacks are the functions that you need to implement in your web server to make it Plug compatible. And let's have a quick look at the function definitions here. So that one's probably the most easy one you just saw. We are sending out a response with the payload, status, header, and body, and we return what I just described. You can also send out a file that's pretty similar, but you just send a file as binary data, offset in length, because you could chunk it. Talking about chunked HTTP requests, that is also supported, so you can initialize a chunked send and then send chunks. You also need a way to read the request body. We implemented this at the very beginning of our journey when we implemented the web server. And that has a little more to return, a little more options to return. And you also have to support HTTP multipart. Multipart is its own set of problems created in the HTTP spec. I don't want to go into too much details. It's basically how you send files from the client to the server. So HTTP uploads, you might have seen that. So that's also supported. And this is everything you need to support Plug from the web server, from the web server side. So it's really just those six functions where the one needs to build up a connection, and that's really all you need to build a web server in Plug. So what's in here? What could you learn from Plug? Well, for me, it was a few things, and when I did this, it was super interesting, and I definitely took a few learnings that I want to share with you. The first thing is that you should pass around modules. Like in Elixir, modules are a first-class citizen. You can just pass them around. Like that's not a big deal. And they also do it in the tuple, where you have the actual like the connection and the module as a tuple. So it looks like one argument that consists of modules. So modules as first-class citizen is really cool. The second thing is structs over gen servers. I always reference to the blog post I linked here from Sasha, who talked about to spawn or not to spawn, where he basically described process boundaries and functional modeling. So it's really interesting. And the one key takeaway I had from this is that structs are architectural design modeling tool. Like you can definitely use structs to design your API and to design your application. You should not use gen server. Like processes are a concurrency design tool, and those are two very distinct things. So design your API using structs, and if you ever need concurrency, then you should only start using Erlang processes or OTP processes and gen server. And the other thing, and while that is like super obvious and probably no news, for me it was a really interesting insight when I was reading Plug and the Plug documentation and the Plug package, is that it's one of the first packages that was created, and actually many of the core maintainers of Elixir wrote it or contributed to it. So there's a lot to learn from the people who invented the language and who built the Hex thing or Phoenix and all the interesting libraries that we all use on a day-to-day basis. You can learn how they write a library, like all condensed in this single Plug API library. That's also not that extensive, right? So that was super interesting. It's basically just implementing two functions, and yet super powerful. So now I talked about all of this, and we're also running short on time. But I think there's one very important question that I'm pretty sure is burning inside you, which is, does it actually work? So if the demo gods are with me, let's give it a try. So yes, no, yes, you can see it. Great. Let's make it a little bigger. So here I'm in the Stupefy code base that I checked out. We can run it. As you can see, I'm running on 4400. And all of this code is on GitHub, so you could check it out yourself. And then I want to make an HTTP request. Oh, it's not big enough. I wanted to make an HTTP request to localhost 4400. And we want to print the request and the response headers and the request and response body. Boom. There you go. So what I really like about that is that what you just saw is all on the slides. Like there's actually no more code hidden anywhere. So what you just saw, all the details, is everything it really takes to make this possible. So that was, to me, when I did all of this, pretty mind-blowing, that it doesn't need that much to get a full working HTTP request response flow. So I brought a few stickers if you want to get them. I also brought a month free of the Ensimple service. If you want to talk about all of that, just drop by. Thank you very much for your attention.